Okay, we have here today another integral from the MIT integration bee from 2006. This one's 19. We have here the integral of square root of secant x tan x dx. Okay, I think there's a few different ways to do this, but one thing I notice here is we have in our expression, we have secant x and we have tan x, and those two work pretty well together. Now, if I was going to do a u substitution on this, I'd probably prefer to do the u substitution for secant x. The only problem is the derivative of secant x is secant times tan x, but we just have a tan x here. Well, what I could do to set up this u substitution is I could just multiply in this secant x so we get our secant x tan x dx right here. I don't want to change it, of course, so we'll divide by secant x. So out here, I'm just multiplying by 1. Now, if we distribute this in and we rewrite this, for this secant of x right here, I'm going to actually we'll write it in this other notation. I'll write it as secant x to the 1/2. Here, we're going to have our secant x tan x dx. And then here in the denominator, we'll write this just as secant x. But then on the secant in the denominator here, I can write this as secant to the 1. So then I can actually just cancel half of these with half of these, and this becomes secant x to the 1/2. But now we're perfectly set up for u substitution, because I can make this my u, and we've got du right here. So let's see how this works. If we do this, so we'll have u equal to secant x, du equal to secant x tan x dx. And let's just go ahead with the substitution. So we'll have u to the 1/2 in the denominator, but what I'm going to do is pull that into the numerator and write it as u to the minus 1/2. So then in order to finish, we just need to do power rule on this. So the integral of this is going to be u to the 1/2. Take this out in the denominator and we get a 2 in front. But we're just going to need to back substitute it in order to finish it off. So for my final solution, we'll have 2. I'll write this as square root of secant x, add a plus c, and that's it. Okay, so there you have it. Quick integral from MIT 2006. Thanks everyone for watching. Have a good day.